Let's say you've got 4 letters and then you have 2 slots. You have 2 slots. How many possible arrangements would there be? So for example, from 4 letters, you can have A, B, you can have A, C, and you can have A, D, and then you can have B, B, A, and so on. How many possible arrangements are there? Well, it turns out that you can use this formula, and we need to understand why this formula exists. Why is it that to work this out? So here, for this one here, there are 4 options. So that would be 4 P, and then 2 slots would be 2. And then if you plug this in, it would be n factorial over 4 take away 2, because R is 2 slots, factorial. So that turns out to be 4 times 2, 4 times 3 times 2 times 1 over, this would be 2 factorial, 2 times 1. So these two cancel out, giving you 4 times 3. It turns out that there will be 12 arrangements, but we need to understand where this formula comes from. So to understand why it is the way it is, why is it that it's 4 factorial and then for some reason it's 4 minus 2 factorial? We need to understand why. So to understand why, in the previous video I showed you that the minute you do 4 factorial, then in your mind you picture all the possible arrangements for this. So it's A, B, C, D, A, B, D, C, and so on. It will list out every single possible arrangements for 4 letters. Now, when you do 4 factorial, you can also visualize this. Visualize a tree diagram, which I showed you in the previous video. A, B, C, D, and then for each branch there will be 3. So that would be B, C, D. And then there will be 3, there will be 3, there will be 3. And then for each one here, you have 2. So this could be CD, and then 2. And then for each one, there will be 2 and so on. Then there's 1, and so on. So when you do 4 factorial, you're looking at all the possible branches. So you're going to list all the possible arrangements for 4 letters. Now, when you have 2 slots, what's actually happening is that you're just looking at, when you have 2 slots, you're just looking at 2 slots. Because look, once you've drawn this tree diagram, you actually discard this bit here, because look at this. A, B is one possible arrangement. A, C is another one. A, C, A, D, and then you've got B, B, A, hang on, C, D. You can have B, A, you can have B, C, and so on. Just by looking at 2 columns, it represents 2 slots. So if you have 3 slots, it represents 3 layers, 1, 2, 3, and so on. Let's go back to 2 slots. So 2 slots, you would look at 2 columns here. So you discard the other 2. So let's start again here. If you want to know all the possible arrangements, in your mind you would do 4 factorial. That means that gives you the whole tree diagram plus all the possible arrangements. But you only have 2 slots. So what you do is you divide it by, you discard this bit here. You discard 2 factorial. Well, you discard 4 minus 2. So that this thing here would represent the other 2 columns over here, factorial. Really, it turns out to be this would be 2 factorial. So when you look at this, it will be 4 times 3 times 2 times 1, which is 4 factorial, and then 2 factorial, 2 times 1. These two cancel out. That's why you only look at 4 here, 4 possible scenarios here, and then each one will have 3. That's why you have this 3 here. Each one will have 3. Each one will have 3. So when you look at the formula, n factorial gives you all the possible branches, gives you this, but then you need to do this n minus r thing, which discards this bit here, giving you 4 times 3, giving you 4 lots, and then each lot will have 3. Hence the reason why you have this formula. So if you have 5 slots, if you have 5 letters, hang on, if you have 5 letters, you're going to have 1, 2, 3, 4, 5, and each one will have 1, 2, 3, 4, 1, 2, 3, 4, and so on. So if you have 5 options, so 5 p, let's say 3 slots. So if you have 3 slots here, 1, 2, 3, you can have A, B, C, and so on. So you want 3 layers. So wait there, 1, 2, 3, 5, 4, 3. Each one will have 3 here. Each one will have 3 here. So for you to work this out, 5 letters and 3 slots, you would have to do, in your mind, do 5 factorial. That will list out all the possible branches and all the possible arrangements with 5 letters. And then, because you've got 3 slots, you want this layer, this column, and this column, which is three columns here. But then you need to discard the other 2. So it will be 5 take away 3. That's this thing here, 5 take away 3 factorial. And then that will discard these 2, leaving you with, well, if you work this out, it would be 5 times 4 times 3 times 2 times 1. And then you divide it by, this is 2 factorial, which is 2 times 1. So these 2 will cancel each other out, giving you 5 times 4 times 3, which is 5. And then which is like 5 lots, and then each lot will have 4, 1, 2, 3, 4, and then this one here, each one will have 3, hence the 3 here. So that's the reason why you have this formula here. Okay.